understands that now better, or we've got a better
Yep.
grasp on that.
Yep.
So now I'm just
Yep.
describing in a centralized manner how you would be able to do spatial pub sub, and we're basically at the point where the client sends a subscribe message, and then what the server would do is it would have a list of all the subscriptions, in other words, the area of interest and who the clients are. And now basically when someone sends a publish message, okay, so let's call it publish. So then you have a packet. And then, okay, now here what you could have is you could just have a location, or you could have an area of effect. Okay, so but the more general case is the area of effect, but it would work for a location as well. Essentially what the server needs to do is it needs to take this packet, and it needs to take, it basically takes the area of effect, right? And it compares it. So let's say you have a bunch of entries over here in your subscription list. So it would compare this area of effect with each of these area of interest and determine, does this area of effect intersect with any of these area of interests, right?
Okay.
If they do intersect, it basically means that this, so let's say it doesn't intersect there, it doesn't intersect there, but it does intersect there. It means that the server then would need to send this packet to whoever that client is. Okay.
Yes.
And
Okay.
if you have that, yeah, so I mean, you could do fancier things as well, where if more than one client has the same area of interest, then instead of having a entry for each area of interest, then you just have multiple entries over there. But that's all optimizations. The basic principle
Okay.
is compare area of interest with area of effect, determine the intersections. Where you have intersections, you need to send this packet to that client over there. And how do you do that?
Okay.
Well, you now know the identification of that client. So then you would just use VAST to say, okay, but please send this packet to that client. And then basically what would happen is that you would once again use this spatial routing mechanism. So you would find the
Yeah.
client's position, and you just use the spatial
Yeah.
routing so that it actually reaches that client. That's one way of doing
Okay.
it, at least. You could probably
Okay.
use, no, if you have the IP address, you could probably use normal TCP IP as well. But that's basically the idea. Okay. So, okay. So now the tricky part is when this is not centralized. Okay, so if you have multiple channels, first what you would do is you would also have a channel over here, right? And the first thing that you
Yeah.
would do is you would just include the channel
Yeah.
information. You would include as well. If it's not the right
Yeah.
channel, then well, you don't even need to do the rest of the checks. So that's how you
Yes.
include channels basically. Now, the problem is the moment that you have a decentralized system, essentially what in my mind, how this works is that each of these nodes, right? So
Yeah.
each of these nodes are basically a server for any packets which are, or any which are published in this region over here. So node 4 is basically a subscription server for this area over here. And node 1 is basically a subscription server for this area over here. So now
Okay.
it becomes, so now when you send a subscription message, you first need to figure out, okay, I want to, so you would probably do something like, so yeah, so each one of these has a list that he needs to keep. And then probably what you need to do is when you subscribe, you need to figure out, okay, but I want to subscribe to a certain area. So that's basically a packet that needs to be routed to the
With
correct
that. Yeah.
node. And then it needs to keep a list of, okay, but what's the area of interests which are in my area over here? And then the other part, okay, so and now whenever someone publishes in a certain area, so now you decide I want to publish in an area, then this node would need to say, okay, but there's something published over here. Who's the guys? So this guy might have subscribed to this area over here, so I need this. He sent a packet to him. He figured out, okay, but this guy and this guy subscribed to the, to the area of effect over there. So I need to forward the packet to them and them. Okay.
Okay.
So that's one way I think of doing a spatial pub sub. And then I mean, if you have a way of subscribing, then you have a way of desubscribing as well. And then it's basically a matter of keeping record of what are the subscription areas, what are the area of effects, and basically matching up who needs to get what packet. The only other problem that you have is when an area of interest intersects two areas, right? Because then what happens? Yeah, because then what happens is that I think, and here I'm not sure what the answer is, but it might be that both this one, this node, and that node needs to or maybe the location is here in the middle. Maybe the packet location is over here, but because the effect is over both the areas, maybe what needs to happen is that this node also needs to send it to that node over there, so it can check if the subscriptions in each area overlaps with the area of effect. So there's a couple of special cases that you also just need to take into account.
Oh, okay.
And I think that's basically the sum, I think, of how you could approach a decentralized pub sub, at least on paper.
Okay. There was one thing that sort of I was reading I don't know how I sort of stumbled onto it, but something about visibility graphs.
Okay, so so Shunyan might be able to pitch in here, but I think what visibility graphs are is that's a measure of your connectivity. So you have a connectivity problem whenever you've got a network like this. So let's say this node, so you've got 100% connectivity when your node can communicate with any other node in your network, right? But if something goes wrong with the Voronoi overlay network, where these two are supposed to be neighbors, but somehow they're not, one of them thinks they're not neighbors anymore, then what could happen is that when you try and route to that guy over there, this link is broken and the message never gets there. So in a sense, and this is where Shunyan must correct me, it means that this node is not visible to that node anymore because it can't send it messages anymore. So what I've explained to you, is my idea of what a spatial pub sub system would be under ideal working conditions. So I think the first approach would be to try and implement this or develop it like that. But then you're also going to have to once that's working, you're going to have to take into account how do you handle failures. What happens when there's an error in the Voronoi network? How do you handle failures to how do you reroute along a different path and things like that?
Okay.
Does that make sense?
Yes.
Yeah, I think he's got another meeting. I think that's what.
Oh, okay. Okay. Thank you, sir. Yeah, this is.
So does this help? Does this help?
Yes. I think it was last night I was reading up on Voronoi and I actually realized I was like noticed especially those boundaries. I didn't look at it as what do you call it? I think I was looking at them as points or something, but not necessarily as boundaries. So when I think of it now and I think of the video Shunyan has, I think about for his master's project, how the boundaries keep moving. It's like as the nodes move, the boundaries are sort of created.
Yes.
And then
So what that is that's these nodes that are actually moving around as well, which means that the Voronoi network basically changes with time. But that's fine, because as long as the idea is basically consistent, even though the Voronoi network is changing, you still have connectivity to your neighbors, and you can hopefully forward your messages to the right place. Okay. So the other thing I should just mention is that you do sometimes get that you have clients that use spatial PubSub, but they do not form part of the Voronoi network. Okay. So you might have, I think, I'm not exactly sure what Union called it. I think he either called it forwarders or he called it matchers or something like that. But essentially what happens is it's as if this node is a, so then what you have is you've got a server client application. You've basically got so you've got a bunch of nodes over here. They're not part of the Voronoi. They don't even have a spatial location, to be honest. Okay. So, so all that happens with them is they're just connected to this node over here via TCP IP or whatever. You know, they just connected to this node over here. They do not form part of the network, but they can still say things like, I want to subscribe to an area of effect over here. So what then, or even I want to publish messages, okay? And then what would happen is that node 4 would basically act as a super peer to them. So they would send all their messages to node 4. Node 4 would then ask the rest of the Voronoi network to route it, to publish it. And, you know, if someone else publishes in this region, it would go to node 4. And then node 4 would then say, okay, but these are the clients connected to me. So which of them needs to, you know, so this is basically this centralized spatial PubSub. So node 4 is basically acting as a centralized PubSub just for these nodes over here. And then you could do something similar for if you have nodes over here and nodes over there. But for now, don't worry too much about that. I'm just saying that if you see
those
this
are
concept
test
of
cases, I mean
potential
cases rather.
It's basically a way for nodes to also be able to use spatial PubSub, but not having to also do routing and you know, be part of the peer-to-peer network. So you can. Okay. So another way of thinking about this is all these nodes that you see over here are essentially super peers, right? And they form the backbone communication network. They're the routers basically of your system, and anyone else just then connects to one of these nodes, and that's their way of being able to publish or to subscribe. They're the base stations basically for your mobile networks, if you want to think about it like that. But now you can do it in a scalable manner, because let's say, for instance, this node's become overloaded. Well, then what you can do is you can just add another node over here. It splits the network, and suddenly this node would need to handle less traffic because there's another guy helping in that area.
Nice. Okay.
So I suggest for tomorrow, I think this session has been recorded. I'm not sure where the recording goes. If it goes to me, I'll just.
It goes into the same place.
Oh, okay, great.
Yeah, nice.
So my suggestion for tomorrow is
not the whole recording. Yeah. Okay. Just after I came up. Yeah. Go ahead. Yeah.
So my suggestion would then be that, I mean, we've talked about this now. Go and write down now, you know, as you talked about in terms of establishing connectivity, how the routing works, and then how the spatial PubSub would work. I would now go and write down, you know, if you want to think about it, the algorithm and how you want it to work.
Yes. Okay.
And then we can perhaps discuss that tomorrow.
All right. That'll be.
Sorry, Shunyun, I didn't realize you're back.
Thank you.
Oh, no, sorry, I was disconnected. Just maybe, I think that was excellent explanation from Herman. Okay, just would like to add that what you can also, what you also consider in a maybe more forwarding manner is that the AOI or AOE, okay, the subscription or the publication, they can be forwarded. I don't know if Herman mentioned about this, you know,
Oh yeah.
for example,
Yeah.
if you want to
So-
like subscribe like a really large area, right? Then potentially
Yeah.
that can be forwarded so that you know, it's being recorded at a more distant node to also match the pub sub records essentially.
Yeah.
Okay. Yeah.
Mm.
So
Okay.
Oh, so
yeah.
is that a basically kind of a backup mechanism as well? Or in other words, you say it's not just this node that is responsible for handling pub sub messages.
Exactly.
You could
Yeah.
also have another guy saying, okay, but you're also responsible for handling messages
Right.
in
Right.
this region over there. Oh, okay.
Yeah, yes, but essentially the criteria is whether, let's say you are doing a subscription, whether the area covers, you know, beyond this the responsible region. Right,
Yeah.
right, exactly. If that's the case, then that gets forwarded.
To
Okay,
everyone
so-
in which this overlaps, basically. Yeah.
Exactly,
Yeah.
exactly,
Yeah.
exactly. And every time it's being updated, it also needs to be forwarded again. You see?
Yes. Yeah.
Because the subscription area, the AOI, that it can move as well.
Yeah.
Okay, so I
So-
mean
so-
that's just, you know, just additional consideration, you know, for
Yeah.
if it's beyond this one region. Yeah.
Mm.
Does that make sense
Okay.
for Victoria?
Yeah. I think I'm gonna look to start putting up the JavaScript code again. Because
Okay.
this actually brings that code back to life to a certain extent.
Yes.
Okay.
Yes.
Okay.
Yes,
Good.
it does.
Yeah.
Yeah. But you can write down the forwarding algorithm. I mean, if you draw a picture like this, then that means you can basically start writing down the forwarding algorithm
Exactly.
pseudocode. Yeah.
Exactly. Yeah.
And once you've done that, you've basically done the design of your algorithm, and then you implement it and check, does it actually work? And that's where you're going to need the vast the vast code, the JavaScript code.
Okay. That's
Cool.
fun.
Okay.
I'll get on that. Thank you very much. I
Okay.
do appreciate your time.
Cool.
Thanks,
It's a pleasure.
Shinyan, as well.
Thanks,
No
Shinian.
problem. All right. So talk tomorrow then, right?
Yes.
Tomorrow morning. Yes.
Okay.
Yes.
All right. Okay.
Cool.
All right. Okay.
Bye.
Enjoy
All
your
right.
day.
So yeah.
Bye.
All right. So good luck. See you tomorrow then. Yeah.
Yeah.
All right. Yeah. Bye
See you
bye.
tomorrow. Yes. Bye.
Bye.